In this video, we'll be learning about rational function. Rational function is a function on the form y equals p of x over q of x, where p of x and q of x are polynomial functions and q of x is not equal to 0, because when q of x is equals to 0, it will lead us to an undefined solution. In this topic, we will be talking about rational equation in which we use equal symbol. And also, we will be talking about rational inequality, which involves the symbol greater than, lesser than or equal to, and greater than or equal to. Here is our first illustrative example. Solve for the variable x in x minus 1 all over x plus 7 equals 9. So here is our solution. For us to simplify the problem, we will try to eliminate the denominator, which is the quantity of x plus 7. So we will multiply both sides by x plus 7. And now we can cancel out the quantity of x plus 7 there. And what we have is x minus 1 equals 9x plus 63. By additive property of equality, that will give us x minus 9x equals 63 plus 1. And then simplify, negative 8x equals 64. And we want to isolate x, then we will divide both sides by negative 8. Then we can cancel out. Then what we have is x equals negative 8. Now let's move on to our illustrative example number 2. Solve for the variable x in x minus 3 over x plus 2 plus 2x plus 1 all over x plus 3 equals 3. So here is our solutions. We need to multiply both sides by the quantity of x plus 2 times the quantity of x plus 3 for us to eliminate the denominator or the fraction symbol. Then that will give us, by distributive property, x minus 3 over x plus 2 there, multiplied by this quantity in the red color, and that will give us the quantity of x minus 3 times the quantity of x plus 3. Then the next term, 2x plus 1 all over x plus 3 multiplied to the quantity in the red color, and that will give us the quantity of 2x plus 1 times the quantity of x plus 2. On the right hand side, we have here 3 times x squared plus 5x plus 6, which is the product of the quantity in the red color. Then to simplify further, and that will give us x squared minus 9 plus 2x squared plus 5x plus 2 equals 3x squared plus 15x plus 18. Then we can see that some terms can be cancelled out, 3x squared on the left side and 3x squared on the right hand side, since we can eliminate that quantities if we are going to use the additive property of equality. Then what we have now is 5x minus 15x equals 18 plus 7. Then simplify that will give us negative 10x equals 25. Then we want to isolate x, then we will divide both sides by negative 10. There, we can eliminate negative 10, and our final answer will give us x equals negative 5 halves. And that's it about solving rational equation. Now let's move on to solving rational inequality. We have certain steps to follow in solving some problems involving rational inequality. So you have there, first, change the inequality symbol to equal symbol. Second, determine the critical points. Third, use shaded circle if the critical point is part of the solution set, and if not, use a hollow circle. And fourth, choose a test point. Then fifth, make an interval notation. Solve for the variable x in x minus 4 over x plus 2 greater than or equal to 3. Step 1, we need to change the inequality symbol to equal symbol. There, from greater than or equal to, we change that to equal symbol. And that's for step 1. Then step 2, we have to determine the critical points by solving for the variable x in our function. So, again, to eliminate our denominator, we will multiply both sides by the quantity of x plus 2, and then we can cancel out x plus 2 and x plus 2 there. So what we have is x minus 4 equals 3x plus 6. By additive property of equality, that will give us x minus 3x equals 6 plus 4. Then simplify. This will give us negative 2x equals 10. Then we have to isolate x. We will divide both sides by negative 2, and we can cancel out negative 2 on the left hand side, and what we have now is x equals negative 5. And x equals negative 5 is the first critical point there. And other critical points can be determined by solving the values of x that makes the term undefined. So since for us to make the undefined solution, we will focus on the denominator of our equation. So there, x plus 2 equals 0, because if our denominator is 0, then it will lead us to an undefined solution. So this will give us x equals negative 2 by additive property of equality. So in step 3, we have to determine if it is shaded or just a hollow circle. In case of x equals negative 5 is shaded circle, since the original problems is greater than or equal to, or use the inequality symbol greater than or equal to. So that makes it shaded, right? Then x equals negative 2 is a hollow circle, since negative 2 will make the inequalities undefined. So meaning negative 2 is not included in the solution. So to give the graphical representation for that, there, negative 5 is shaded and negative 2 is hollow circle. And these are our critical points. Then in step 4, we need to find test points. If it makes the inequality true, then it is the solution. So we'll find numbers lesser than -5 and I'll choose -6. And we'll find numbers in between -5 and -2 and I'll choose -3. And we'll find numbers or number greater than -2 and I'll choose -1. Then we'll start solving or testing for -6. So from the original problem, x minus 4 over x plus 2 greater than or equal to 3, substitute -6 to x, and that will give us -6 minus 4 all over -6 plus 2 greater than or equal to 3, and that will give 5 over 2 greater than or equal to 3, which is false because 5/2 is lesser than positive 3. Now let's test for -3. Substituting -3 to our original problem, this will give us -3 minus 4 all over -3 plus 2 greater than or equal to 3, and that will give us 7 is greater than or equal to 3, and that is true. So meaning numbers in between -5 and -2 are the solutions of our inequality. Then let's try to test numbers or number greater than -2, which is we select -1, substituting -1 to our original problem, and that will give us -1 minus 4 all over -1 plus 2 greater than or equal to 3, and that will give us -5 greater than or equal to positive 3, which is false. So therefore the only solutions are numbers from -5 to -2, but we will not include -2 because if our x is -2, it will make the rational inequality undefined. So therefore, the numbers greater than -2 are not included. There is our solution. Alright. So in step 5, we have to make our notation. Then from that solutions, we can say that our x is greater than or equal to -5 but lesser than -2, and that is our final answer.